So, when I was talking about mean median mode, I have told one thing that median and mode can are two measures of central tendency which can be calculated from the graph. So, how these can be calculated from the graph will be discussed. For discussing that, I have considered the following example, which was also considered for the numerical calculation of median and mode. In the data, wages and number of workers are given. Now we have to compute the median and mode using graphs. So first computation of median from graph. The median can easily be obtained with the help of cumulative frequency curves. Or you can say it can be easily obtained from the ogives. There are two methods for computing the median from cumulative frequency curves. First method have following steps. First, draw the cumulative frequency curves of both the types. Then, from the point of intersection of both the curves, draw perpendicular to the axis of class interval. The point at which this perpendicular intersect the axis of class interval is median. So first, for drawing the cumulative frequency curve of both the types, the cumulative frequencies must be calculated. So I have calculated the cumulative frequencies of less than type and more than type. Or you can say less than type and greater than type. So I am repeating again how these cumulative frequencies are calculated. First, less than type cumulative frequency. So first less than type cumulative frequency will be same as frequency. Then next cumulative frequency will be obtained by adding first cumulative frequency to next frequency. That is, first one will be 52, next one will be 52 plus 68, that is 120. Then next one will be 120 plus 85, that will give 205, and we will proceed to up to last, which will give 590. In same manner, for more than type cumulative frequency, start adding one by one from last interval. That is, first cumulative frequency of more than type will be 28. Next one will be 28 plus frequency, that is 28 plus 70, which will give 98. Next one will be 98 plus 100, that is 198. And in same manner, we proceed upwards, and last cumulative frequency will be 590. Now, less than type cumulative frequency will be plotted against upper limit, whereas more than type cumulative frequency will be plotted against lower limit of the class interval. That is, 52 will be plotted against 180, 120 will be plotted against 190, 205 will be plotted against 200, and so on. Similarly, for more than type, 590 will be plotted against lower limit, that is 170, 538 will be plotted against 180, 470 will be plotted against 190, and so on. So in this manner, the cumulative frequency curves of less than type and more than type are constructed. So here we can see at this point, these two ogives are intersecting. From this point, we draw a perpendicular to the axis of class intervals. That is this one. Here we can see it is intersecting at the value 210. So we can say that median of the given data is 210, which is obtained from the graph. Whereas when we have discussed the numerical calculation, it is obtained that the value of median is 209.78. That is, from graph we can get an approximate idea about the median. However, if we calculate in proper manner through graph using scales and different things, then we will obtain the value of median exactly as 209.78. Now second method. In second method, we draw only one of two cumulative frequency curves, either less than type or more than type. Then we mark the point n by 2 on the axis of cumulative frequency. From this point we draw a perpendicular on the axis towards the cumulative frequency curve. The point where perpendicular intersect the cumulative frequency curve, we draw a perpendicular to the axis of class interval. And the point at which this perpendicular intersect the class axis of class interval would give median. That is in such manner. First we mark two axes, one for class intervals, other for cumulative frequency. Then we draw cumulative frequency curve. I have drawn less than type cumulative frequency curve. Then there was to 590 total frequency, that is capital N was 590. So half it will give 295. Then here from this point, that is it is will be 290 from 95. From this point we draw a perpendicular, that is a line making angle of 90 to the axis of cumulative frequency towards cumulative frequency curve, that is this line. On this point, this line is intersecting the cumulative frequency curve, and from this point we draw a perpendicular to the axis of class interval, or you can here see it is class limits. Again it is intersecting on same point, that is 210. So we can say that median is 210. Again from calculation it was obtained that median was 209.78. So this method also give an approximate idea about the median. So we can calculate median either from graph or from calculation, but it should be remembered that cumulative frequency curve should be drawn in proper manner. Some persons drawn both the cumulative frequency curve starting from upper limit of first class interval, whereas some person drawn both cumulative frequency curve starting from lower limit, that is less than type starts from 170 and more than type starts from 170, or both starts from 180. But in proper manner, low less than type cumulative frequency curve must be started from upper limit of first class interval, whereas more than type cumulative frequency curve must be started from the lower limit of first class interval. Otherwise the calculation will show some error by using graph. Now how we would compute the mode from the graph? The mode is computed with the help of histograph. For computing the mode from histogram, following steps are used. First step is draw the histogram. Next step is select the bar of histogram having maximum height. That is highest bar should be selected. Then from upper left corner of this bar, draw a line towards the upper left corner of next bar. Similarly, join the upper right corner of highest bar to the just preceding bar, that is upper right corner of previous bar, using a straight line. These two lines intersect at a point. From that point, draw a perpendicular to the axis of class interval. The point at which the perpendicular intersect the class axis of class interval will give mode. So that is, first we draw histogram in this manner. Here you can see the maximum height of, sorry, the bar having maximum height is this one. That is, this bar is selected. From this corner of bar, we join the this point, that is corner of next bar, and from this point we will join the corner of previous bar. That is, draw this line and this line. Here at this point these two lines are intersecting. From this point we draw a perpendicular to the axis of class interval, that is this one. Here line is shifted somehow, and this this is starting from 170, so this line is 220, and we can make a guess that this point will be 221. So from graph it is obtained that the approximate value of mode is 221, whereas from calculation it is also obtained that value of mode is 221.43. So in this manner we can also make an idea about the mode from the graph. By using proper instruments for constructing graph and making measurements, we can obtain exact value of the mode from the graph. Now some other measures of central tendency. The first the first measure which I would discuss is geometric mean. Geometric mean is another measure of central tendency which is used for quantitative data. It is basically used when average is required for the data which changes with time. That is, when it is required to measure the average relative changes, then geometric mean is used. The geometric mean is nothing but the nth root of product of n observations. For raw data, it is given by the formula geometric mean capital G is equals to x1 into x2 into so on xn whole power 1 upon n. It can also be written in symbol as this one, that is pi I goes 1 to n xi whole power 1 upon n. Somehow it is difficult to calculate power 1 by n manually, so it can be transformed in the terms of log and anti-log. So in terms of log and anti-log, the formula of geometric mean would become anti-log of 1 upon n summation I goes 1 to n log xi on base 10. For class interval data, the formula of geometric mean can be written as G equals to pi I goes 1 to k xi whole power fi. Sorry, geometric mean is pi I goes 1 to k xi to the power fi whole power 1 upon summation fi. Here product is goes 1 to k, so summation will also goes from 1 to k. By mistake it is written as 1 to n, or both terms will go 1 to n, or you can say 1 to k. Pi means product of n terms, so it will be x1 to the power f1 into x2 to the power f2 so on xk to the power fk. And summation fi can be also written as capital N, which is total frequency. In terms of log and anti-log, we can write geometric mean for class interval data equals to anti-log of 1 upon summation fi into summation fi log of xi. How these are computed? So for computing the geometric mean using raw data as well as for class interval data, I am considering the same example which was considered for the calculation of mean, median and mode. However, I have reduced the size of raw data. Actually, it was 35. I have taken only 14 observations. So for calculating geometric mean, these observations are denoted by xi, then its log is taken over base 10. These are log of xi. Then these logs are added up. That is sum. So sum of log of xi is 21.105. So we can, from calculation, it is obtained that summation I goes 1 to 14 log xi is equals to 21.105. Now we take its average, that is calculate the quantity 1 upon n summation log of xi. That will give 21.105 divided by 14, that is equals to 1.508. Now geometric mean will be anti-log of this quantity, that is g is equals to anti-log of 1 upon n summation I goes 1 to 14 log of xi, that will give anti-log of 1.508, and from table the value of this anti-log comes out to be 32.175. So geometric mean of given data is 32.17. Similarly, for class interval data, the data of wages and number of workers is taken. First, we calculate class mark from the wages, that will obtain by using upper limit plus lower limit upon 2. Then that class mark represents x size. Then we take the log of these class marks, which will give for 175 it is obtained as 2.243, for 185 it will comes out to be 2.267, and so on. Then multiply number of workers to the log of xi, that will give fi log xi. So for first class interval it would be obtained as 116.638, for second it will be obtained as 154.168, and so on. Then we these fi log xi's are added up, that is sum is obtained, that is obtained as 1367.811. Now this summation is divided by total frequency, which would give 1367.811 divided by 519, that is obtained as 2.318. Now anti-log of this quantity will be taken, that will provide geometric mean. That is geometric mean is equals to anti-log of summation 1 upon summation fi multiplied with summation of fi log xi. That will give anti-log of 2.318, that is equals to 208.125. That is geometric mean of the given data is 208.125. Now again, each measure have certain properties or certain characteristics which are defined in terms of merit and demerits. So the merits of geometric means are, it is rigidly defined and based upon all the observations. Geometric mean is also suitable for measuring the relative changes. It is less affected by extreme values, or you can say values which are very much high or very much smaller as compared to other variables, as it takes nth root. And it is also not affected by the fluctuations of sampling, or you can say sampling fluctuations. However, it has certain drawbacks. The main drawback is that it is difficult to calculate. If we are calculating it manually, then it is very much difficult to calculate the geometric mean. It cannot be calculated if at least one value is negative or zero, because the nth root of negative value is imaginary, whereas the square root of zero is undetermined. Geometric mean can also not be calculated when observations are missing. It cannot be calculated if the class intervals are of open-ended type, and it cannot be used for qualitative data also. These are the drawbacks of geometry. Now we come to harmonic mean. Harmonic mean is also a measure of central tendency, which is used for quantitative data only. It is basically used when average is required for the ratio or rate of some quantities, like velocity of average velocity or average growth rate, etc. In that situation, harmonic mean is used. Harmonic mean is inverse of the arithmetic mean of inverse of n observations. That means Harmonic mean h is given by 1 upon n summation I goes 1 to n summation 1 upon xi. So for remembering the formula of harmonic mean, we start from backside. N observations, that is x1 x2 dot 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 xn. Then inverse of n observations, that will become 1 upon x1 1 upon x2 1 upon xn. Then arithmetic mean of inverse of n observations, that means add these inverse and divided by total number of observations, that will give 1 upon n summation I goes 1 to n 1 upon xi. Then harmonic mean is the inverse of arithmetic mean of inverse. That means we have obtained the inverse, just sorry, we have obtained the arithmetic mean. Now just invert it. So arithmetic mean was 1 upon n summation I goes 1 to n 1 upon xi. So harmonic mean will become 1 upon n summation I goes 1 to n xi. In case of frequency distribution, harmonic mean is obtained by using formula h is equals to 1 upon summation I goes 1 to n fi into summation I goes 1 to n fi xi whole inverse. So these are the formula of harmonic mean. However, formula look likes very difficult, but it is very much easy to apply. That you can see with the help of examples. Again, certain characteristics of harmonic mean that are similar to geometric mean, that is, it is rigidly defined and based upon all the observation. It is not affected much by fluctuations of the sampling. It gives more weight to the smaller value, whereas less weight to the larger value, as we are taking inverse. So value will be in decimal. When we invert it, it will become in terms of hundreds, whereas larger value comes out to be zero point 0.1 or zero point 0.2. Harmonic mean is also less affected by extreme values as compared to arithmetic mean. Again, its demerits are same to the geometric mean, that is it is difficult to compute. It cannot be calculated if at least one observation is negative or zero. Sorry, harmonic mean cannot be calculated if at least one value is zero. In case of negative value, harmonic mean can be calculated. Harmonic mean cannot be calculated if at least one observation is missing. It cannot be calculated for open-ended class interval, as well as it cannot be calculated for qualitative data. Again, using same example of 14 observations, I have calculated the harmonic mean. So for calculating harmonic mean, first invert the observation. That is, observation was 20.7, then first will become 1 upon 20.7, then 1 upon 29.3, then 1 upon 34.4, and so on up to last value. Then sum these inverse, which will give you provide the value 0.454. Now the harmonic mean will be obtained as inverse of average of these values. These 1 upon xi, that is, divide this quantity by 14. So harmonic mean will become 1 upon 0.454 divided by 14. That is 1 upon 0.0324, which will give the quantity 30.852, which is the harmonic mean for the data. Similarly, for calculating harmonic mean for the class interval, first calculate class mark by using formula upper limit plus lower limit divided by 2. Whereas intervals must be of exclusive type. Then fi upon xi, that is number of workers divided by class mark. That is, first value will become 52 upon 175, second value will become 68 upon 185, and so on. Last value will be 28 upon 245. Then sum these values. The total frequency will be 590 and sum of fi upon xi will become 2.848. Now harmonic mean will be summation fi xi divided by summation fi and then inverse of this quantity, that is 1 upon 2.848 divided by 590. It will give 1 upon 0.00483, which will provide the value of 207.174. So harmonic mean is 207.174. Along with measure of central tendency, some other values are also important, but these are not the measures of central tendency, but from a statistical point of view, these are important. These values are called as partitioning values. These values divided the data set into a number of parts. These partitioning quantities are generally of three types called as quartiles, deciles, and percentiles. The quartiles divide the data into four equal parts. These are, and for dividing the data into four equal parts, only three quartiles are needed, which are denoted by first, second, and third quartile, and denoted by Q1, Q2, and Q3 respectively. The ith quartile is given by, for raw data, value of I by nth term, where I takes value 1, 2, and 3. That is 1 upon n, 2 upon n, and 3 upon n. For frequency data, the ith quartile is given by Qi equals to L naught I plus I n by 4 minus Ci divided by Fi into H. I takes value 1, 2, and 3. So if we are talking about first quartile, then it will become n by 4. For second quartile, it will become 2n by 4, that is n by 2. And for third quartile, it will become 3n by 4. L naught I is lower limit of class interval for ith quartile, that is decided in same manner we have decided median class, and in median class we have used n by 2, here we use I n by 4. Ci is cumulative frequency before the ith quartile. For the class before ith quartile, Fi is frequency of class of ith quartile, capital N is total frequency, and H is width of class interval. Now how these quartiles are interpreted? The quartiles, first quartile can be interpreted as, it is the value below which 25% of observations lies and 75% of observations would be more than it. That is 25% of observations would be smaller than first quartile, whereas 75% observations will be greater than first quartile. For second quartile, 50% observations will be smaller and 50% of the observations will be larger than the second quartile. Same property holds for median. Therefore, we can say that second quartile is nothing but the median of the data. For third quartile, 75% values will be smaller than the third quartile and 25% of observations will be larger than the third quartile. Second partitioning value is deciles. It divides the data into 10 equal parts. There would be 9 deciles, first, second, third up to ninth decile, denoted by D1, D2, so on Dn. The formula can be written in the same manner as quartile. The value of ith decile will be value of I by nth term. Here I takes value 1, 2 to n. For frequency data, the value of ith quartile can be obtained by using formula di equals to L naught I plus I n by 10 minus Ci upon Fi into H. Again, I takes value 1, 2 to n. And for deciding the class of ith decile, we use the quantity I n by 10. Third partitioning value is percentile. As per its name, percent is calculated always in terms of 100. So percentile divides the data into 100 equal parts. And these are terms as first, second up to 99th percentile and denoted by P1, P2 up to P99 respectively. Again, the formula of calculation is same. So the val, the formula for raw data is value of I by n term. I changes from 12 to 29. For frequency data, it will here in percentile, in decile we use 10, in quartile we use 4, and in percentile we use 100. That is ith percentile is given by L naught I plus I n by 100 minus Ci into Fi, sorry, L naught I plus I n by 100 minus Ci upon Fi into H. And again, lower the class of ith percentile would be decided by using in by 100, and where cumulative frequency become just greater than in by 100 will be termed as the class of ith percentile. So it is the end of today's